So let's start out looking at the reference sheet that I gave you with the unit circle on it and the table of sine, cosine, tangent ratios. Okay, so the diagram shows equivalent degrees and radian measures for special angles that you're going to be using a lot in trig. The most important ones, or I guess the ones that you're going to be using the most, is the 30, 45, 60, 90. So to know those radian measures, that would be very helpful for you in the future. And down here in the bottom in this table, it shows you the sine, cosine, tangent for 30, 45, 60 degree triangles or angles. So those are the ones that you use the most in trig. Okay, so let's look on your study guide, page 17. Make sure you're on the right page. Page 17, yep. Trig functions of general angles. So let's just read through the notes and then we'll do a couple of examples. Let theta be an angle in standard position. And standard position is just when you start the angle from the positive x-axis and the vertex is at the origin. Let P of xy be a point on the terminal side of the angle. By the Pythagorean theorem, the distance r from the origin is given by r equals the square root of x squared plus y squared. The trig functions of an angle in standard position may be defined as follows. The sine of theta is y over r. Cosine of theta is x over r. Tangent of theta is y over x. X cannot be 0. Okay, so that's specified because sometimes your angle is going to be on the x-axis or on the y-axis, and so they tell you that x can't be 0 because that would make your fraction undefined. You can't divide by 0. The cosecant of theta is r over y. Y cannot equal 0. Secant of theta, r over x. X cannot equal 0. And the cotangent of theta is x over y, where y cannot be 0. So on this diagram that they show you on the left, they're actually using this smaller reference angle to get the ratios. Okay, and we're going to talk more about reference angles on the other side of the sheet, but I just wanted to point that out, that your reference angle is the one that's used to get the sine, cosine, tangent ratios of a larger angle. So first thing I want to do, and you might want to add this diagram to the bottom of the reference page that I gave you. It'll help you look when you're looking up your sine, cosine, tangent for some of the angles. In your coordinate plane, you know, your sine, cosine, tan ratios. So y over r for sine, x over r for cosine, and y over x for tangent. So sometimes those values are going to be negative and sometimes they're going to be positive. It depends on what quadrant you're in, because even though r is always going to be positive because it's a distance, x and y sometimes are negative because of the different quadrants, right? So for example, in the first quadrant, your x and your y are both positive values. So that means that your sine ratio is positive, cosine ratio is positive, tan ratio is positive. In the second quadrant, your x value is negative, but your y value is positive. So looking at your ratios, you can see that cosine and tangent both are going to have negative values because it involves y. So sine is positive, cosine is negative, and tan is negative. In the third quadrant, you have both x and y negative. So looking at your ratios, you're going to have one negative value for sine, so that makes the whole thing negative. Cosine, x is negative, so that makes your ratio negative. But for tangent, since x and y both are negative, that's going to make it positive. So your sine is negative, cosine is negative, tan is positive. And in the last quadrant, x is positive, but y is negative. So that means your sine is going to be negative because it has the y. Cosine positive, tan negative. Okay, so we'll use this later in the lesson. That'll help you out a little bit. All right? Okay, so moving on. Let's look down at the bottom of your page on page 17. Number 1, says the terminal side of theta in standard position contains each point. Find the exact values of the 6 trig functions of theta. So both your values are positive, so that means you're going to be in the first quadrant, which all of your trig ratios will be positive then. So the first thing we need to do is find the value for r. R is the square root of 8 squared plus 4 squared. That's the square root of 64 plus 16. So that's going to be the square root of 80. And when you simplify that, then you'll get 4 radical 5. And that's your r value. Okay, so I'm going to move this to where I'm going to have a little bit of room. So my sine ratio is y over r. Sine of theta is y over r. And then you want to reduce. You need to simplify. So these 4's are going to reduce out. So you're actually going to have 1 over radical 5. And then you need to rationalize it. You can't leave that radical in the denominator. So we're going to multiply top and bottom by the square root of 5. And your sine ratio is going to be the square root of 5 over 5. Okay, now the cosecant is the inverse of your sine ratio. So I'm going to use the very beginning one. I'm not going to use the one that was rationalized because that's going to put another radical in the denominator. But if I use the one at the first, then it's going to flip it over where you get square root of 5 over 1, or just square root of 5. Cosine ratio is x over r, so that's going to be 8 over 4 radical 5. And again, we need to simplify. The 4 and the 8 can reduce, and I need to rationalize it. Multiply top and bottom by square root of 5. So your cosine is 2 radical 5 over 5. Okay, the secant ratio is going to be the inverse. Now I'm going to use my original, my unrationalized cosine ratio. Flip that over, so we'll get square root of 5 over 2 for the secant. And tangent is y over x. Oops. And you always want to simplify or reduce it. So tangent's going to be 1/2. And that means that the cotan is 2, right? Okay, any questions?